Once said, education is the most powerful weapon which you can use to change the world. Hi everyone, welcome back to yet another mathematics video with my dad, Albert. Bye!
Hello everybody, welcome back yet to another video. So this is a follow-up video in the previous one, and we're going to do some questions, work some actual questions. Alright, so the previous video was conceptual. Alright, a lot of notes, a lot of building on your knowledge about sets, definitions, and notations. Alright, so let's begin. Alright, so looking at this question here, it says a universal set U is defined as the following numbers. Alright, so we have 15 going up to 25. Alright, so basically we have two sets. We have prime numbers and we have even numbers, right? I know that prime numbers only itself and one are the only factor, meaning that only one and the number itself can go into it without leaving a remainder. For example, 17. 17 is a prime number because only 1 and 17 itself can go into that, into 17 without leaving a remainder. Alright? And also we have 19, which is a prime number, and 23. Alright, so let me just try and squeeze this in. So we have for prime numbers, we have 17, we have 19, and we have 23. So those are our prime numbers. So that's set M. Set N now, we have even numbers. And you know even numbers are numbers, and when you divide that number by 2, you get remainder 0. So our first even number there is what? 16. We have 16. 18, 20, 22, lastly 24. Alright, so just draw a Venn diagram. So in drawing a Venn diagram, we're going to use a rectangle here, and you know that rectangle represents the universal set, and the circles represent the set themselves. So we have two sets, M and N. Alright, so let us, before we even draw this thing here, right? You know, when you're drawing a Venn diagram, circles can go various ways. Sometimes they intersect, sometimes they don't. Alright, and sometimes you get a subset, like one is a part of the other. Alright, so let's look at these two sets. as you can see, there are no numbers that are common. So the circles won't touch. Well, they can touch, you know, but if they touch, if they intersect, you can't put no number in the center. All right. So I because there's no numbers common, I'm not gonna let them touch. So this is set M, and this is set N. And this is 17. I don't enough space, so we'll put an arrow there. So 17. So you're gonna write all those numbers in the M circle. All right, all of these numbers in the N circle. All right. But you notice that we have a few numbers on the outside. So these numbers are neither in set M nor N. So these numbers turn out to be, we have here is 15. We also have 21. And also we have 25. So those elements are on the outside. And which will answer the second part of the question. It says list the elements of the set M union N complement. Alright, now M union N without the complement is everything that's contained in sets either in M or N. So M union N complement means that everything that's outside the circle. So it says to list, right? So you're gonna have your brackets 15, 21, and 25. All right. Sometimes they ask you how many elements are in the set. It would have been 3. All right. So I hope you guys following. All right. Let's move on to the other slide. All right, so let's examine this question. So the total number of elements in set P is 5. So this entire area here, all of that area, and you know that part of set P touches set Q. All right, so some of this 5 here also is contained in Q. All right, likewise Q. All right, so all of Q is 9, but some of that 9 is also contained in P. All right, and this question says P union Q. So P union Q means that all the elements in either P or Q, which is equal to 10. All right, so the question is asking us, what is P intersect Q? In other words, we want to know what number goes in here. Alright, so we don't know, so let's call it X. Alright, so if X is right in the center here, then over here is going to be P subtract X, meaning we're subtracting what's common between P and Q from the total number of elements in set P. And over Q, we're going to do the same thing. We're going to have 9 subtract X. Same reasoning. Now, when you add up all of this, it should be equal to 10. All right. So let's add these. So we have 5 subtract X plus X plus 9 minus X, and everything should be equal to 10. Alright, so right away, minus X plus X will be eliminated. That turns out to be 0. Alright, so end up with 5 plus 9. By the way, 5 plus 9 is 14. We write back the negative X. put everything equal to 10. Everybody see that? Right. So you can always click back on the video and listen to what I said. So our next step now is to solve for x. Alright? So what I'm going to do is that I'm going to put this, well, just by looking at this statement here, this x has to be 4. So 4 from 14 is actually 10. Alright? But you can also solve this algebraically, but I don't want to go into that right now. So we're just using reasoning and logic to say that x is equal to 4, because 4 from 14 is 10. So x is equal to 4. And x will be what is common between set P and set Q. Alright? So if I want to know how many members are in P only, not P and Q. So it will be, it's 1, right? X is 1. So 1 from 5 is what? 4. We know that x is what? X is 4 also. And this is 4 subtract 9, which is what? 5. Alright? Now if you were to add up all these numbers here, oh, sorry, I made a mistake here. X is 4, right? Right, but I put 1 there. Sorry about that. So 4 from 5 is actually 1. Alright, so what happened a while ago? I was adding up the whole thing, you know. I'm supposed to get 10, whereas I don't get 10. I know something went wrong there. Alright? So all of us are prone to errors, not true? So sorry about that. But anyways, 4 from 5 is 1. X is 4. 4 subtract 9 is 5. So if I were to add up everything, you're supposed to get back to 10. And that's one way of you guys doing to check to see if your answer is correct. So 5 plus 4 plus 1 is actually 10. Alright, so moving on to the next slide, or the next question. Alright, so this one is pretty straightforward. It's not mathematical, it's just notes. It says, give an example of a set that is equivalent to this set here. So what you're probably gonna ask yourself is that what is a equivalent set? Alright? So when you have two sets that have the same number of elements but not necessarily the same elements, then the two sets are equivalent. So for example, you have a set 1, 2, 3. You have a next set A, B, C. Those two sets are equivalent. Alright? So let's just give an example. So you know, you can just put anything. You could put like probably I don't know, like 1, 2, 3, 4, 5. I mean, you could put anything. You could put days of the week, weeks, alright, months of the year, as long as we have the same number of elements. So as you can see, we have 5 elements. So you have to have 5 elements. So these two sets are equivalent. They're not equal, but they are equivalent. Just a note here. Let us say that this is set P and this is set Q. Alright, there's a symbol that we use. We say P, equivalent symbol. Oops. It's like half of an arrow going one way and half of an arrow going the other way. So it's set P is equivalent to set Q. So that's the symbol for equivalency. Let's move on to the next question. Alright, so it says in the figure below, X represents the set of multiples of 4 and Y represents that should be, sorry, that should be, and y represents the multiples of 6. So there's a little typo there. So y represents, it should read y represents the multiples of 6. All right. So we have two sets here, x and y in this Venn diagram, and x are the multiples of 4. So the question says the shaded region represents a set of all the multiples of a. So basically, which multiple is common between 4 and 6? So let us write out the multiples of 4, a few of them. So the multiples of 4, so we have 4, so let's start with 4, so we have 8, we have 12, 16, 20, 24, 28. So the multiples of 6 are 6, 12, 18, 24, 30, etc., etc. All right, so it goes on. All right, now what do you notice? 24 is a common multiple between 4 and 6. All right, so I would say 24 will go here. So 24 is a multiple of x, and it's also a multiple of y. All right. So moving on to the next question. All right. So what we have here is that we have 3 sets. We have a set T, K, and E. Those are even numbers, prime numbers, and odd numbers. All right. So it says, which of the following set is empty? So an empty set is a set that has no elements. It doesn't exist. All right. And the symbol that they use to represent the empty or null set is in the previous video. All right. So let's look at this carefully. So let's look at the responses. Set A. It says T intersect K. Now T intersect K means that there's something common between set T and set K. All right. So is there anything common between even numbers and prime numbers? Is there a number that's even and prime at the same time? Yes, it's 2. All right. So set A actually exists. So A wouldn't be the answer. All right. So let's try that out. All right. So let's look at C. It says K union T. All right. So basically, do we have K union T? Do we have something that is either even numbers or prime numbers? Well, yeah, it's the same too. All right. So C1. All right. So let's get to the answer. Answer there is B. Is there anything common between set T and set E? In other words, do we have any even number that is odd? Or do we have any odd number that's even? Can't think of a number. So that set will be an empty set because it doesn't exist. I can't think of any even number that's odd or any odd number that's even. All right, let's move on to the next question. All right, so we're given the universal set and we're given set R. All right, so question says then R complement is. So R complement means what's not in R. So if you notice, you take out 9, take out 22, take out 109. R complement would have been 3, 7, 17, 45, and 51. So that's your answer. So remember, complement means what's not in the set. All right? All right. All right, next question. It says, all the students in a class play dominoes or chess or both. 47% of the students play dominoes only, and 22% of the students play chess only. What percentage of students play both games? All right, so the key word here is it. Now you notice that the question didn't say 47% of the students play dominoes. It says 47% of the students play dominoes only. Likewise, chess what? Only. Meaning that the 47 and the 22%, there's no mix between who play domino and chess. All right? So basically, if we want to know what's in the center, all right, all we need to do is what? Add the 47% for the dominoes with the 22% for the chess, and then subtract it from 100. All right, so we have 100, subtract 47 plus 22. All right, so 47 plus 22 is what? 69. Oh, sorry, this should be a subtraction. And when we subtract 69 from 100, we get what? 31. So 31% of the students play dominoes and chess. All right, so we're gonna move on to the next question. All right, so if V is a set and V is M and P, how many subsets can be obtained from set V? All right, so basically we want to know how many subsets we can get out of this set. Well, the question didn't say to list them. All right, just say how many. But just to give you a snapshot, the empty set is a set that you can take from that set here. The set itself, M, N, and P, we can take M, we can take N, we can take P, All right. So these sets you can take from set B. You can also take Mn. You can take MP, member of parliament. No? We can take NP. All right, so what's the total? Total subset is what? 8. All right? So the answer is 8. However, we can use a formula. But the question didn't say to list the subsets, just state the number of subsets. So this is the formula you can use. It's 2 raised to the power of n. So what does n represent? N represents the number of elements you have in set B. And how many elements we have in set B? 3. So it's 2 to the 3. And what's 2 to the 3? 2 to the 3, well, 2 to the 3 is not 6. 2 to the 3 is 2 multiplied by 2 multiplied by 2. And strange enough, some persons even will still write 6. But 2 times 2 is 4. 4 2s is 8. Alright, so 2 to the 3 is actually 8. So we use this formula. 2 raised to the power of n. So remember, n represents the total number of elements in the set. So for example, if I had another element here, like say cube, it wouldn't be 2 to the 3 now, it would be 2 to the what? 4. Alright? And anybody, can someone tell me what 2 to the 4 is? 2 to the 4 is actually what? 16. So you can get 16 subsets when you have 4 elements in a set. Alright. So we're doing okay? Alright. Alright. So let's examine this. Alright, so we have X and Y are 2 finite sets. What's a finite set? A finite set is just a set that you can count, a countable set. If I say that R represents the total number of stars in the universe, that would be an infinite set. Alright, so a finite set is a set that you can count, or countable sets. Alright, so this is saying that now we have 9 elements in set X, and we have 4 elements that share between X and Y. That's an intersection there, that's in the center there. And the union was either in X or Y is equal to 50. And the question says, what is the total number of elements in set Y? Alright, so what I'm going to do, I'm going to draw a Venn diagram to represent the information given. Alright, so let's draw a little rectangle. So because they intersect, you see, the 2 circles will meet. So we have X, set X, and we have what? Set Y. Let me put the U there. I think I forgot to put the U in the previous question. All right, so when you're doing these questions, right, always try to figure out what goes in the center. So basically, 4 will go there, 4. All right, now what does this mean? This means everything that is in X is equal to 9. So this area of the circle is not X, it is called X alone. So if I want to know what goes over here, I would have to subtract 4 from the 9. And 4 from 9 will give us what? 5. Alright? So basically what it's saying, 5 members of set X have nothing to do with Y. Alright? But the total is still what? 9. Alright? Okay. Now, It says X union Y equals 15. So remember I told that when you add up everything, you're supposed to get what? 15. All right, so what number should we must put there? So 5 plus 4, 5 plus 4 is what? 9. All right, so 9 plus what will give us 15? Has to be what? Has to be 6. Yes, has to be 6. So check this out now. What is 4 plus 6? 10. What's 10 plus 5? 15. All right. All right. So what's the answer then? Answer is not 6, you know. But the question asks us, what is the total number of elements in set Y? And that will be 4 plus 6, which is what? 10. All right, moving on to the next question. All right, so we're almost to the end of, let me see how many questions we have remaining. 1. Wow, that's our last question. All right, so this one, okay, so this is very similar to the previous one, basically. They just change up the numbers. All right, so let's draw a Venn diagram. So we have two sets, set P and set Q. All right, now what's common between P and Q? How much of them? 6. So you notice I always go for that one, the two, one in the center. And P union Q is equal to 13. That means that if I add up everything, it must equal to what? 13. Now they give us that the total number of elements in set P is equal to what? 9. All right, so do I put the 9 right here? No, you don't do that. All right. So what you're going to do, you're going to say 6 from 9 is what? 3. So 3 is what goes there. All right, as you can see, 3 plus 6 will give us what? 9. All right. So we need to figure out which number goes there, true? And that's Q only. So 3 plus 6 is 9. So 9 plus what number gives us 13? That turns out to be what? 4. Let's add it now. 4 plus 6 is 10. 10 plus 3 is 13. So what's our answer? Well, the answer is not 4. What the question asks us? What's the total number of students? Sorry, not students. What's the total number of members in set Q? It will be 6 plus 4, and we get 10. All right, guys, so this is the end of this presentation. I hope you find this video very informative, and thanks for watching, and I'll see you guys again. All right, take care, take it easy, keep safe.